This will be a continuation of my series on electromagnetism. In this video, I'll be looking at the ideal transformer. You can find this topic in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses in my stand store at this web address. If we wind two coils on a steel core, we can cause almost all of the flux to link both coils, and we can further hypothesize the case in which 100% of the flux is linked by both coils. In this ideal case, it is called an ideal transformer. Now, let's input a sinusoidal AC voltage on the red coil on the left. This is known as the primary winding. This AC voltage will cause a small current to flow in the primary coil. The amount of current flowing is limited by the reactance of the primary coil. In an ideal transformer, this reactance is 100% inductance, so the current will lag the voltage by 90 degrees. This current is known as the magnetization current. Remember that any time a current flows, it will produce a magnetic flux proportional to it, which means it too is sinusoidal and in phase with the current. And since we are dealing with an ideal transformer, all of that flux flows in the iron and links both coils. Considering the primary coil, we will measure a voltage drop. This voltage drop we'll call V1 across its terminals, and it will be equal to the applied voltage, VAC, because it's directly connected to the applied voltage. In coil 1, the flux produced by the generator is related to the voltage V1 by Faraday's law, which involves the changing flux times the number of turns in the primary coil. In the coil 2, the secondary coil, the voltage produced by that same flux by mutual inductance is also given by Faraday's law, which involves the same changing flux but times the turns in the secondary coil. That voltage is either larger or smaller than V1 depending on N1 and N2, the turns of the primary and secondary coils, but it is in phase with the applied voltage VAC. Anker has just released a peek at their most advanced multi-device fast charging lineup. In order to check out this advanced lineup, simply go to this web address. This video is part of my Electrical Technical Information series. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of aforementioned products and is also the connection to obtain a free copy of my 50-page electrical power crib sheets.